Hello everyone. This video is on section 9.8 titled Solving Quadratic Inequalities. So in this video I'm going to be going over a version of the Knewton Alta assignment for section 9.8. Now please understand that the questions I see in this version may not be the same questions that you see when you work on the assignment on your own. But the objectives are the same, and the types of questions that you see should be similar. So I'm hoping that watching me go through these here will help you in some way when you work on it on your own. Alright, so here's the assignment page. You will not see the words preview of, right? You'll just have the title of the assignment, and then the mastery bar telling you how far along you've gotten. Then below that, the objectives. Right, it looks like there are 2 objectives in this particular assignment, but both involve solving a quadratic inequality. One way is graphically, and another way is algebraically. And I'll go over both methods, but really they give you the same result, and you just pick which one you like better, really. And then you have a question related to the current objective beneath that. And at the bottom of every question, there should be a feedback button for which you can send feedback to Knewton. There should also be a more instruction button. Right, you'll click on this if you ever have any troubles, and it'll provide you with further reading material, and/or videos to help you out. And you will not see the instructor cheat button, right? That is not going to be there. Alright, so this first question, I'll go over how to solve a quadratic inequality graphically. So this is going to involve graphing a quadratic function, which you should know how to do from previous sections in chapter 9. Alright, so I'll write out this inequality here, and we're asked to solve, and write the solution in interval notation, right? What values of x make this a true statement, right? When is x squared minus 11x plus 28 going to be greater than 0? Going to be positive, right? Alright, so here's the inequality we're given. Again, it's x squared minus 11x plus 28 is greater than 0. Alright, so I'll write out the steps over here that I'm going to be following for solving one of these quadratic inequalities graphically. Now the first step is going to be the same for solving any quadratic inequality, whether it be graphically or algebraically. I'm going to get the inequality in the following form, where you have the quadratic on one side, right, ax squared plus bx plus c, and then is greater than 0. Now that could be is greater than, is less than, is greater than or equal to, is less than or equal to, okay? But just, I want to set this up so that we have everything on one side, right, a quadratic polynomial on one side, and 0 on the other side of the inequality symbol. Alright, then we're going to graph, right? Again, this is a graphing. We're going to graph the quadratic function. Y equals ax squared plus bx plus c. Alright, so take the quadratic polynomial and consider the quadratic function involving that polynomial. So after this example here, let's look at the function y equals x squared minus 11x plus 28. Alright, so remember how to graph this. Remember how we, this is again going back to section 9.7 part 1 and part 2. Alright, talking about graphing quadratic functions. First, make sure it was in that y equals, ax squared plus bx plus c form, which it is. Then I found, the axis of symmetry for the parabola, which I'll be abbreviating AOS for the rest of the video. Now the axis of symmetry, that was a vertical line that cut the parabola down the middle. It had the vertex on it. And that was x equals, a vertical line, so it was x equals some number. And that was the opposite of b, right? And I'll refresh your memory here. That was negative b over 2a, right? So positive 11 divided by 2, right? 2 times 1. And then I'll start making a graph, Just going to do a rough hand sketch of this function here. X-axis, y-axis. Now 11 halves is 5.5. So here's 5, here's 6. Right, 11 halves be right in the middle of those two. Alright, so this line, this axis of symmetry, is x equals 11 halves. That marks off, the middle of the parabola, where the middle is going to be, where the vertex is going to be. Now for these particular, for these inequalities, I'm going to put an emphasis on finding the x-intercepts. If any, right? Remember, sometimes a parabola won't cross the x-axis, but I'm going to put emphasis on finding the x-intercepts instead of the vertex, right? I know normally I would then find the vertex, but I'm going to go about finding the x-intercepts next. Alright, so let's do that. I'll grab some paper here. Alright, so let me cover my graph up a little bit and then I'll come back to it. So the x-intercepts, remember you let y be 0. So we're solving this equation, right? 0 equals x squared minus 11x plus 28. And then you solve. Now you can use the quadratic formula. Right? This is in a form where I can, everything's on one side, zeros on the other. I can use the quadratic formula if I wish. I can solve by completing the square, right? Or factoring if it's factorable. And this one is factorable. This factors to x minus 4 times x minus 7. Right, so x equals 4 is a solution to this. X equals 7 is a solution. So the x-intercepts are the points 4, 0, and 7, 0. Right? And I'll mark those on my graph. Right? 4, 0, and 7, 0. So here's 4 on the x-axis. Say here's 7. And I'm marking those points. Alright, so once I know where the x-intercepts are, right, and the axis of symmetry, that's all I really need to be able to draw enough of a sketch of the parabola to help me solve the inequality. And I'll show you what I mean here in a second. Now looking at this here, I got my intercepts, right, 4, 0, and 7, 0. The lead coefficient, right, a equals 1, which is positive, Right, that means the parabola opens up, opens upward, right, like that. So if I know where the intercepts are and the axis of symmetry, right, I don't really need the vertex here. Again, I'm just making a very, very rough sketch to help me solve the inequality. I know it's got to open up. It's got to do something like this. Right? Like something like that. Right? Again, that's a very rough sketch of the parabola. But it's enough. Right? It's enough to know where the x-intercepts are and how the parabola is opening. To know where the parabola is located to be able to solve these inequalities. Because now I'm doing this. Remember what I did in the beginning? We had x squared minus 11x plus 28 is greater than 0. Trying to figure out where this is happening. What values of x? Well, if we consider the function y equals x squared minus 11x plus 28, if I replace the x squared minus 11x plus 28 with y, right, this is all of a sudden the same as, for what values of x is y greater than 0. Right? For what values of x is y greater than 0, because I'm looking at the function y equals this x squared minus 11x plus 28. Alright, so looking at the graph, looking at my graph here, remember the y values are positive above the x-axis, y values are negative, right, less than 0 below the x-axis, and y equals 0 on the x-axis. And then looking at the graph, we can tell what values of x give me positive y values, right? They want this value here, right, to be greater than 0, to be positive. So, and again, always going left to right on the x-axis, always low to high, and I'm going to draw these in interval notation. So from x goes from negative infinity up until 4, the y values are positive, right? The graph is above the x-axis. So from negative infinity up until positive 4, but not including positive 4, right? Because positive 4 for x gives me 0 for y, not greater than 0. So positive 4 wouldn't be a solution. So I'm putting parentheses on that. And then you see from 4 to 7 on the x-axis, the graph is below the x-axis. The y values are negative, less than 0. That does not satisfy this inequality. I want y values greater than 0 on the graph of this function. Y values greater than 0. Again, back on the graph. So the values from 4 to 7 aren't part of the solution set. And then we have a union. Remember when there's multiple intervals connected? We're going to put a union symbol. And then from 7 onward, 7, 8, 9, 10, and so on, from 7 up, the graph is above the x-axis, meaning the y values are greater than 0, or the value of x squared minus 11x plus 28 is greater than 0. So from 7 to positive infinity, right, the outputs are positive. Always parentheses on infinities. And then just like 4, 7 itself is not a solution. Right? When I plug in 7, the value of the function equals 0. It's not greater than 0. So parentheses on the 7 to indicate that it's not a solution. And here we go. These are the solutions of our original inequality. All right, and you can test it out. Pick any value less than 4. Pick any value less than 4, say 3210, negative 5.2, negative a million, whatever. Plug it in for x, and the value on the left will be greater than 0. Same thing for these numbers. Pick any number greater than 7, plug it in, and this will be greater than 0. And this is what I'm going to enter in the assignment, right? They want us to enter this solution set in interval notation. So, parentheses, negative infinity up to 4, right? But not including 4. Oh, what happened there? And then a union symbol, right? Which I need to go to the sets area for, it looks like, for the union symbol. And then parentheses again, 7 comma, and then positive infinity. So back to the basic keyboard. And there we go. All right, the interval notation for the description of all the solutions, all the values of x you can plug in and make this inequality a true statement. All right, and then after every question, all right, whether you get it correct or incorrect, there is an answer explanation. I would highly recommend reading through these, whether you're right or wrong. If you're correct, read through them to make sure you got it right for the right reasons. And if now they actually found the vertex, and then when they look at, see, they actually found the vertex and the x-intercepts and graphed it. I'll tell you right now, if you can find x-intercepts, you really don't need the vertex. But if you can't find x-intercepts, then you need the vertex. Right? We'll probably see examples like that later. But yeah, read through and see that that you got it right for the right reasons, that you didn't just get lucky. Or maybe they do it in some alternate method that you like better, that you'll use for future questions. Now, if you got it wrong, definitely read through the answer explanations and make sure you can figure out why you were wrong, right, and learn from your mistakes for future questions. All right, so the next question is on the other objective, right? Solving. Now, you're going to be doing the same thing. You're still solving a quadratic inequality. All right, but they say algebraically this time. So without drawing a graph of a parabola. So this is just without a parabola. The way you would do this is still very similar. I'm gonna take everything to one side, 0 on the other, and then look at that quadratic polynomial and find where it's equal to 0. So basically like finding the x-intercepts of a parabola, and then we'll go from there. All right. So what I'm going to do for this particular example, these examples, is going to be very similar to how we solved rational inequalities, if you recall that. All right. All right. So here we have x squared is less than 15x minus 7. Alright, so once again for this other method, now both methods are equally valid, solving these quadratic inequalities graphically or without a graph of a parabola, right? Just algebraically. So I'm going to go through again both of them, and then you decide which one you like better, and you can always use that method. Right? You don't have to switch back and forth. You can choose to use the same method every time, and you will end up with the proper solutions to the quadratic inequality. Alright, so the first step was just like the last one. Get everything to one side. So I want a quadratic polynomial on one side, and then is less than, or is greater than, or is less than or equal to, greater than or equal to, one of the 4 inequality symbols, and then 0 on the other. Alright, so that's not done yet. Alright, that's not done yet. Now me personally, I like having a positive coefficient on the x squared term. So I'm going to leave x squared where it is on the left side, and then take away 15x and add 7. So we get x squared minus 15x, then plus 7, and then all I did was subtract and add, so the inequality symbol doesn't change, so that still is less than, and then I have 0 on the other side. Right, so that's the first thing. All right, get a everything on one side, 0 on the other. Then I'm going to find the critical values. Now if you recall, this is very similar, and I'll abbreviate these CVs in future problems. These critical values, this is very similar to when we were solving rational inequalities, right? Getting a fraction on one side and 0 on the other. So here I'm just looking for the numbers that make the polynomial 0. So basically, these are the values of x, or values of the variable. In this case, it is x. Values of x that make ax squared plus bx plus c, that quadratic polynomial, equals 0. Alright, so here we have our quadratic polynomial is x squared plus minus 15x plus 7. And again, the is less than 0 I'll worry about later. And the question I want to answer is, where is x squared minus 15x plus 7, where is that equal to 0? Right, find these critical values. Alright, so I'm solving a quadratic equation now. And it's set up in a fashion where I could use the quadratic formula for completing the square, or try factoring. Now I'll tell you right now, this is not factorable. Alright, this is not factorable. So I'm just going to use the quadratic formula. So the solutions here are, now I'm not going to write out the quadratic formula this time. You should know what that is by now. It's the opposite of b, the linear coefficient, so positive 15. Then plus or minus the square root of, and then b squared. Now negative 15 squared would be 225. Minus 4 times a times c. Now 4 times a is 4, times c is 28. Right, minus 28, and then all of this divided by 2 times a, 2 times 1, which is just 2. So we have 15, plus or minus the square root of 197. 197 is 225 minus 28. And I don't believe that'll simplify any further. Is this not a multiple of 2? It's not a multiple of 3. Not a multiple of 5. Not a multiple of 7. Not a multiple of 11. Now 130. 67. Yeah, it's not a multiple of 13. And I believe that's it. Alright, so then all this divided by 2. Alright, so this gives me 2 solutions. Alright, then I'm going to make a number line. Alright, I'm going to put the critical values on a number line. Alright, so we have the number line here. This number line, say, represents all the possible values of x. And we have, 15, here's 15 plus the square root of 197 divided by 2. And then obviously less than that would be 15 minus the square root of 197 divided by 2. Right. Now, what I'm going to do is put these critical values on a number line and check if they're solutions. Are these solutions to the inequality? Well, remember, if I plug either of these numbers in, we'll have 0 on the left, right? Because it'll make x squared minus 15x plus 7 equals 0. So if I plug either of these numbers in, I'm getting 0 on the left is less than 0. Is 0 less than 0? No. So this is not a solution, meaning I'm putting an open point above it. Remember, open points for non-solutions and closed points, filled in dots for numbers that are actually solutions. And then an open point here as well, right? Neither of those are solutions. And then just like with those rational inequalities, now the critical values, right, they break up the number line into 3 intervals. There's this interval, to the left of 15 minus the square root of 197 all over 2. And then there's between the two, and then to the right. Now, if you'd like, I'm going to put these in a calculator to get an approximation. Let me know about what values these are, so I know what values to pick in the intervals. Now, 15 minus the square root of 197 divided by 2. This is about 0.48, and then 15 plus the square root of 197 divided by 2 is about 14.52. Just to give me a rough idea as to what numbers I can plug in. So now I'm going to plug in a value from each interval and test for solutions, right? Just like with rational inequalities. Alright, so again, this is the inequality I'm looking at. Right, x squared minus 15x plus 7 is less than 0. So over here, to the left, this interval to the left of, about 0.48, I'll pick 0. Let's test 0. Now if I plug in 0, we're getting 7 is less than 0. That's false. So this interval doesn't have solutions. All right, this interval doesn't have solutions. Then between these two numbers, right, about 0.48 to about 14.52, I'll pick 1. All right, the number 1 is in there, or 2 or 3 or 14, whatever. Now if I plug in 1, we'd have 1 minus 15 would be negative 14 plus 7 would be negative 7 is less than 0. That's true. So when I plug in 1, it works. It satisfies the inequality. So that means these numbers, all right, this interval between 15 minus the square root of 197 over 2 and 15 plus the square root of 197 over 2, that interval of numbers between those satisfies our inequality. So I'll mark that off. And then to the right of this, say I pick an easy one like 20, something, a multiple of 10. If I plug in 20s to the right of this further right number here, 14.52-ish, that'd be 400 minus 300, be 107 on the left. Is less than 0 on the right? No. So the numbers over here to the right of 15 plus the square root of 197 over 2, these are not solutions. So the only numbers that are solutions to this inequality is between these two here. And that's what I'll do. And then in the interval notation for this, right, so the solutions in interval notation, going left to right, low to high all the time. We have this interval here, this piece of solution starts at 15 minus the square root of 197, all divided by 2, comma, up to 15 plus the square root of 197, all divided by 2. And parentheses on either end, because those numbers themselves were not solutions, right? I had open points, and this is what I'm going to be entering, right? This right here, this interval. All right, so let's go back and do that. So back to the assignment. We have just the one interval, right? So parentheses, and we have well, I should put it in parentheses again because there's multiple terms in the numerator. 15, pardon me, minus the square root of 197. Get out of there, and then all that divided by 2, then a comma, and then I'll just copy and paste this first value and change the minus to a plus. And then close the parentheses on the interval. All right, and that should be good. Wonderful. All right, and once again, right, read through the answer explanations. All right, you see they did exactly what I did, a number line, and then you're picking values, test numbers from each interval, and all that, just like I showed you. Right, this is without graphing a parabola. Now I'm going to tell you right now, of these two methods, graphically with a parabola involved, or algebraically, I prefer graphically, right? Because drawing a rough sketch of the parabola you need is going to be pretty simple if you know where the x-intercepts are, right? And also which way it opens. Does the parabola open up or down? Alright, so from here on out, I am going to be doing these graphically. Alright, I just wanted to show you at least one of them algebraically. This will be the only one. Right. Okay. So the next one is solve, another one graphically. Again, I'm just going to keep doing it graphically. If you want to do it algebraically, you can do that too. Alright, just go back to that second example and see how that was done there. Alright, so I'll write this out and we'll work on it. Alright, so this is already set up the way I wish to solve these, right? Everything on one side, 0 on the other. So now we'll look at y equals, we're going to look at the function y equals this quadratic polynomial here, negative x squared minus 3x plus 18. Right. Which, it's pretty easy to find the intercepts here. This one's actually nice and factorable. If I pull out a negative 1, you'd have x squared plus 3x minus 18 as the other factor, and then you could factor that also to x plus 6 times x minus 3. Alright, so if it's already factorable, man, that's going to be real easy to find the x-intercepts, right? So here's the x-axis. And I'll put a y-axis somewhere, doesn't matter, right? I'm hoping it's obvious that the x-intercepts are negative 6 comma 0 and 3 comma 0. Right? So I'll mark those down. There's negative 6 on the x-axis. Here's positive 3. And there's a point of the graph there, a point of the graph there, and it's opening down. Now the axis of symmetry, I'll put that in as well, right? So you know where the halfway point, where the vertex should be. Again, I'm not going to find the vertex. That's really unnecessary here. Be x equals, negative b over 2a. So 3 over negative 2, that'd be negative 3 halves, negative 1.5. So the axis of symmetry is here. And the value of the lead coefficient is negative 1, right? Y equals negative 1x squared. So that's negative means, opens down, right? The parabola opens down. These are all properties you saw, back in section 9.7. So I have the x-intercepts, and I know it opens down, so it's got to look, again, I don't know where the vertex is. I don't really care right now. But I do know that the parabola opens down. So it should look something like this. All right. And that's really all we need. Now just pay attention to what we want on the right side of the inequality, right? I want to know where is y, right, the negative x squared minus 2x plus 18, where is y less than or equal to 0? So when you're talking graphs, this means on or below the x-axis. Because if the y values are less than 0, you're below. And if the y value is equal 0, you're on. So I can show you right now the solutions. Right, the solutions are in my picture here. From negative, I'm only focusing on the x-axis though, right? My solutions need to be values of x for the original inequality. What values of x make that a true statement? So going left to right on the x-axis, from negative infinity up to negative 6, the y values are less than 0. They satisfy the less than 0 part. But then negative 6 itself is also a solution because it makes the y value equal 0, and that satisfies the equal to part. So I'm putting a bracket on that. Right, a bracket on negative 6. And then from negative 6 to positive 3, the y values are positive. So not less than 0, not equal to 0. So these are not solutions. Right, from negative 6 to positive 3, those are not solutions. Now from positive 3 onward, right, so a union, because there's a separate interval here, from positive 3 to infinity, those values are solutions to this inequality. Right, when I plug these values in, the output is negative, is less than 0. And when I plug 3 in, the value is equal to 0. So again, I got a bracket on 3. 3 is a solution. And here we go. All right. And really, that's all you're really going to need is, know the x-intercept, get everything to one side, 0 on the other. Find the x-intercepts of the quadratic function and know which way it opens, right? If you can find the x-intercepts and you know which way it opens up or opens down, you should easily be able to tell where the graph has positive y values or negative y values. Right? Now, if you can't find x-intercepts, right, if there are no x-intercepts, then you need to find the vertex. Right? But we haven't seen an example like that yet. We might. All right. So back on the assignment, that's the interval I'm going to enter. So parentheses, from negative infinity, comma, up to negative 6, and then a bracket. And the union symbol, which I need to go to sets for. and then bracket again from 3 to infinity. Close the parentheses, and there we go. Wonderful. And once again, please read through the answer explanations. Alright, now I know it says, do it algebraically, but as I said earlier, I'm going to do all the rest of these graphically because they give you the same result. And I did the one example algebraically, and that's the way you would do all the algebraic ones if you wanted to. But the graphical method also gives you the same solutions, and I find it a lot easier for people to do if you remember how to graph parabolas, how the graphs of parabolas go. Alright, so I'm first taking everything to one side. We have x squared minus 8x, and then I would add 2, and to get plus 2 over here, is greater than or equal to 0. And now we're looking at the following function. I look at y equals this quadratic, x squared minus 8x plus 2. Alright, and then we'll, graph it. The axis of symmetry is that x equals, positive 8 over 2, so x equals 4 is where the axis of symmetry is. So I'll write that off over here. Do a little dotted line, x equals 4, the axis of symmetry. Now I'm going to find the x-intercepts, if it has any. Right? So that's where we're solving this equation. When is y equal to 0? When is 0 equal to x squared minus 8x plus 2? Which I can solve this by completing the square pretty easily. If I subtract 2 here, and then we complete the square on x squared minus 8x, you'd be adding 16 to both sides. So I have 14 over here, and then x squared minus 8x plus 16 is x minus 4 squared. Alright, so the solutions are x equals 4 plus or minus the square root of 14. Alright, now the square root of 14 is between 3 and 4 units. So one of the intercepts is here, 4 plus the square root of 14. Right, there's 4 plus the square root of 14 on the x-axis, and the other x-intercept is at 4 minus the square root of 14. 1, 2, 3, 4, so somewhere here. Right. There's 4 minus the square root of 14. So I got the x-intercepts. Right. Now I'm just going to say, hey, the lead coefficient is positive for this quadratic polynomial, this quadratic function. So this is going to open up, right, as a positive lead coefficient. So the sketch of the graph of this parabola is looking like this. Again, very rough, very rough. All I'm doing is trying to figure out, where the graph is above the x-axis and where it's below. Right. Because now we're trying to determine where is, y greater than or equal to 0. Now greater than or equal to 0 means above or on the x-axis. For what values of x is this true? Well, again, only looking at x values here, what x values make this inequality true? From negative infinity up until 4 minus the square root of 14, we have positive outputs, values that are greater than 0. And 4 minus the square root of 14 makes it equal to 0. So all these numbers satisfy, right? So the solutions, we have from negative infinity up until 4 minus the square root of 14, And then, 4 minus the square root of 14 is also a solution, so I got a bracket on that. And then from 4 minus the square root of 14 up until 4 plus the square root of 14, the values of y are negative, right? They wouldn't satisfy this inequality. This would be false, because we're looking for when is the output greater than 0 or equal to 0. And then from 4 plus the square root of 14 onward, right? So for in union with the interval from 4 plus the square root of 14 up into infinity, including 4 plus the square root of 14, right? Because that makes it equal 0. And then every value after that makes it positive, makes it greater than 0, so satisfies this inequality. So here we go. Right. Here we go. All right, that's the intervals that I'm going to enter in the assignment. Right, so this first one, right, from negative infinity, comma, and then 4 minus the square root of 14. Get out of there. Bracket, then the union symbol, and then left bracket, and then 4 plus the square root of 14. Get out of there, comma, and then infinity, parentheses, and that should be good. Wonderful. But yeah, you see how I didn't have to test a value in each interval and all that. Just knowing the intercepts alone, the x-intercepts alone, and also which way the parabola will open up, right, based on the lead coefficient. Right? If it's positive, it'll open up. If it's negative, it'll open down. Just knowing that stuff alone will help me solve these. Right, and again, read through the answer explanations if you want to see how they're doing things algebraically. All right. So again, I'm going to be going, I know it says algebraically again, but I'm going to be doing it graphically because I find that easier. All right, and so I'll write this out and we'll do it on paper. All right, so once again, first thing I'm doing is taking everything to one side. So we have x squared plus 7x, and then subtracting 1, minus 18 is less than or equal to 0. And now I'm looking at the graph, right? We're going to look at the function y equals x squared plus 7x minus 18. Now, lead coefficient's positive, so it's going to be opening up. I'll make that little note here off to the side. The axis of symmetry is x equals negative 7/2, right, or negative 3.5. I'll mark that in a little graph over here. Negative 3, negative 4, and then negative 7/2. Like that, right? There's the axis of symmetry. Then the x-intercepts. Solving this equation, right? 0 equals x squared plus 7, or replacing y with 0, right? X squared plus 7x minus 18. This, I'm going to use the quadratic formula this time. X equals, well actually no. No, actually this one's nice. This factors, this is x plus 9 times x minus 2. Right? Yeah, that'd be x squared minus 2x plus 9x for 7x, and then minus 18. So negative 9 and positive 2. 5, 6, 7, 8, 9. And positive 2. Right, so the intercepts here are at negative 9. There's a point on the parabola, positive 2, 2 comma 0. And as I said earlier, it opens up. So the parabola is going to look something like this, right, with the middle of it, the vertex being on this axis of symmetry. Alright, so the graph is above the x-axis to the left of negative 9. It's below the x-axis, negative y values between negative 9 and positive 2 for x. And then to the right of 2 on the x-axis we get positive values for y. Well, if you look at the inequality, we're looking for where is this y, x squared plus 7x minus 8, where is the graph of this function, less than or equal to 0? Now, again, less than or equal to 0 means on or below. On for equal, below for less than the x-axis. And that's only happening here, right? From -9 to +2, including -9 and +2. Right? For all the values between -9 and +2, the output is negative. It's less than 0, so this inequality would be satisfied. And for -9 and +2 itself, the value would be equal to 0, so still the inequality would be satisfied. And that's it, right? Every other value makes the values positive, makes the y value positive. Greater than 0, not less than or equal to. So here's the interval I'm looking for, from -9 to 2, including -9 and 2, right? Brackets on those. So bracket -9, comma 2, another bracket. Great. Alright, and read through the answer explanations. Again, they're doing it algebraically. Right, like I showed you with that first example on algebraic, I showed you how to do it, that one time in this video. But like I said, I prefer graphically. It gives you the same solutions. Alright. And I got one more here where again it says algebraically, but I'm going to do it graphically. Alright, no big deal. You get the same solutions. Alright, so once again, first thing I'm starting with is taking everything to one side. So we have -x squared plus 17x minus 4 is less than 0. Now, if you don't like having a negative lead coefficient, we can multiply both sides by a negative number, but you just have to remember that the inequality symbol will flip. All right, if I multiply both sides by -1, that would flip. So I'm just going to leave it like this. All right, so we're going to look at the function now. Y equals, -x squared plus 17x minus 4. The axis of symmetry for this particular function, the parabola, would be x equals -17 over -2. So positive 17 halves. Alright, so I'll just put that here. I'm not going to be crazy accurate. I'm not going to do too much drawing this time. So here's 17 halves. I know it's on the positive side of the x-axis, right? So I got the axis of symmetry in. Now the x-intercepts. I'm just going to jump right to the quadratic formula. Got -17 plus or minus the square root of 17 squared be 289. And then minus 4ac. Now a times c here, -1 times -4 is +4. So 4ac is 4 times 4 is 16. So it's -16. All this divided by 2 times a divided by -2. Right. So -17 plus or minus the square root of, let's see, minus 269 plus 4, 273. Yeah. Alright, and this is 3 times 91, right, 273. Yeah, I don't think that'll simplify any further. 3 times 91. 91 doesn't break down any further. I believe 91 is prime. Yeah. No, 91 is, no, 7 times 13. but this is 3 times 7 times 13, so no perfect squares in there. Yeah, so that doesn't simplify any further, and all that divided by negative 2. So we have, dividing each of these numerator by negative 2, we have 17 halves, right, positive 17 halves, and then plus or minus, because it'll turn to minus, plus, plus, minus, it doesn't matter. Square root of 273 divided by 2. Alright, so one of those is to the right of 17 halves. There's, say, 17 halves plus the square root of 273 divided by 2. And then the other one is the same distance, but on the left side. I don't know if that's going to be positive or negative. It doesn't matter. I'm just putting a point on the x-axis here. Here's 17 halves minus the square root of 273 divided by 2. And as I said, we know, well, I didn't say that, but we know this parabola is down, right? The lead coefficient is negative. So this parabola is going to look something like this. Again, very, very rough sketch. It's got to open down. Right. And we are looking for, what values of x give me a y value less than 0. And less than 0 means below the x-axis on this graph. So that's these values here, from negative infinity up until 17 halves minus the square root of 273 all over 2. And that's not a solution because it makes the value equal 0, not less than 0. So I'll put parentheses on that. Or these values over here, from 17 halves plus the square root of 273 over 2 to infinity, right? These values give me y values less than 0, would satisfy this inequality. And again, a parenthesis on this because, 17 halves plus the square root of 273 over 2 makes this equal 0, not less than 0. And there you go. Right. I know it's a little funky with the square roots and everything, but still the interval will be entering. Alright, so first interval, negative infinity, comma, and then 17 halves minus the square root of 273, then that divided by 2, close parentheses, then the union symbol, and then parentheses, and then I'm just going to copy and paste this value. Change the minus to a plus, comma, infinity, and close parentheses. Okay, this should be good. Great. Alright, so now again, I know it's the algebraically is done, but I'm going to stick to graphically, right? And you can again run through here and look at how they do it with a number line algebraically, and I did this before, with the first example of the algebraic objective. Alright, so the rest of them they're asking, I'm just going to do this again, I'm doing the same procedure, same method, I'm going to do it graphically. Should be, again, just as simple. Okay, so this one's already set up the way I want, right, where everything's on one side, zeros on the other. So now I'm looking at this quadratic function, y equals x squared plus 4x plus 3, which is, you can see, is factorable. That actually factors to x plus 3 times x plus 1. Right, so the x-intercepts are at negative 3 and positive 1. Or sorry, negative 3 and negative 1. Negative 3, negative 1. There's where the x-intercepts are. The axis of symmetry would be at x equals negative 2. Right. And the parabola is opening up. So it's got to look something like this. Alright. So you see how quick that can be sometimes? I mean, I know I didn't talk it out a lot. I didn't write a lot. But I know it's opening up because the lead coefficient is positive. I can see the x-intercepts would be at negative 3 and negative 1, and it's got to open up. And we're looking for values on the x-axis that make this expression less than 0 or equal. So that's just this area here, right? Below the x-axis or on it, right? So that's from -3 to -1, including -3 and -1, and those values only. And that's what I'm entering, right? It can really be that quick. So bracket, -3, comma, -1, bracket, and submit. Alright. And again, please read through answer explanations. Alright, looks like we got just one more of these with a graph. Great. Alright, and now once again I will write this out and do it on paper. Alright, so this is again set up in the way I want. Everything on one side, 0 on the other. We're going to look at the parabola y equals -x squared minus 8x minus 12. Now, again, if you see it, great. If you don't, use the quadratic formula to find the x-intercepts. But I can see that this is factorable. Right, if I pull out a -1, you'd have x squared plus 8x plus 12, which factors to x plus 6 times x plus 2. Alright, so the x-intercepts are at -6 and -2. Alright, so -6 and -2, meaning that the axis of symmetry is halfway between those at -4. Alright, if you did the negative b over 2a, it would be x equals -4 for the axis of symmetry. And this opens down, right? It's got a lead coefficient that's negative, so it's got to look something like this. Opening, and a parabola opening down. Alright, and now I'm looking for values of x, right? Values on the x-axis here, the horizontal axis, such that this inequality is satisfied. The value of this expression is greater than 0 or equal to 0. That's these values here. Alright, if you're greater than 0, that means the y value is above the x-axis, and equal to 0 is on. So that's from x equals -6 to -2, including -6 and -2. There's your interval of solutions. Alright. All the other values give me negative y values, would make this less than 0, not greater than or equal to 0. Alright. Now, if you can't see how to factor things, right, use the quadratic formula to find the x-intercepts, but you're still doing the same stuff, pretty much. Alright, and then this last interval here, the solution set for this inequality is brackets, from -6, comma, to -2, bracket again. Great. Alright, so yeah. Same steps for everything, every single one of these I was doing, right? You take everything to one side, 0 on the other, and then you're graphing a parabola, right? Or at least making a rough sketch where I was finding the axis of symmetry, the x-intercepts, and if there were any. And if you knew where the x-intercepts were and how the parabola would open, right, using the lead coefficient to determine that, then you could very easily tell where the solutions were, right? What x values made the graph above the x-axis for greater than 0, or below the x-axis for less than 0, or on the x-axis for equal to 0. And then you drew your intervals from there. Alright, so that should be it for this version of the assignment. Alright, as I said at the top of the video, right, the questions I saw here may not be the same questions you see when you work on the assignment yourself, but please understand that the objectives are still the same, the questions are similar, so I'm hoping that watching me go over these 8 questions here, help you in some way when you work on the assignment on your own. And thank you very much for watching.